Hi, this is Matt, and in this video we're going to go over the mathematics of dilutions and calculating unknown concentrations. These calculations are of course important when going through questions, but most importantly, these calculations are very useful in the laboratory. So the first question we have to ask ourselves is, what exactly is a dilution? Well, a dilution is when the concentration of a solution is decreased, usually by adding more solvent, and the amount of solute remains the same. Remember how the solvent is the liquid we're dissolving something in, and the solute is what's being dissolved. So in salt water, salt would be the solute, and water would be the solvent. Now that last part with solute remaining the same is very important. That means that when we dilute a solution, the amount of moles dissolved does not change. All that changes is the concentration and the volume. Remember how our general formula for molarity is that concentration, or M, equals the number of moles divided by volume, or that the number of moles equals the molarity times the volume. Since the amount of moles doesn't change, we could set the initial concentration multiplied by the initial volume equal to the new concentration multiplied by the new volume, as shown by this equation here. M1V1 equals M2V2. So, now that we know the formula, let's try a question. A student starts off with 100 milliliters of a 3 molar PbO aqueous solution. The student diluted the solution to 0.75 molar. What is the new volume? So two things to look at before actually doing the problem. First, the AQ in parentheses after the compound, that just means it's dissolved in water. Secondly, you'll notice how the volume here is given in milliliters. Often with concentration, we would have to convert that to liters. But when we use M1V1 equals M2V2, we actually can leave it in milliliters, as long as we remember our answer will be in milliliters as well. So now, let's try solving this question. You'll realize the first thing I did was write the equation, M1V1 equals M2V2. Secondly, I listed my givens. It says that we start off with an initial concentration of 3 molar and an initial volume of 100 milliliters. It then says our new concentration is 0.75 molar, and we will now plug in to find the new volume. So plugging in, we get that 3 molar multiplied by 100 milliliters is equal to 0.75 molar times V2. You'll notice how I plugged in with units. We don't need to keep the units through the whole question, but when we initially plug in, we want to make sure those units are there to get full credit. So after combining the terms on the left side, we get that 300 equals 0.75 times this new volume. So then we would divide by the 0.75 to get the new volume alone, and dividing 300 by 0.75, we get that the new volume of the solution would be 400 milliliters. Moving on to another question, now let's try solving for the initial volume. So a student starts off with a 5 molar NaCl aqueous solution of unknown volume. The student diluted the solution to a volume of 250 milliliters and a concentration of 3 molar. What is the new volume? So as always, I'm going to write my equation, M1V1 equals M2V2, and then write my givens. The initial concentration is 5 molar, the new concentration is 3 molar, and the new volume is 250 milliliters. So plugging in, I get that 5 molar times the initial volume is equal to 3 molar multiplied by 250 milliliters. So then combining the terms on the right side, we get 750. So we get that 5 times the initial volume equals 750. Lastly, we divide by 5 on both sides to get that the initial volume is equal to 150 milliliters. Now that we've worked through calculating volume, now we're going to start using this equation to find unknown concentrations. So first, let's try to find the initial molarity of a solution. So a student dilutes 450 milliliters of KBr aqueous to get a 900 milliliter solution with a concentration of 0.8 molar. What was the initial concentration? So first, I'm going to write out my equation, M1V1 equals M2V2, and then I'm going to list my givens. We know that the initial volume is 450 milliliters, the new concentration is 0.8 molar, and the new volume is 900 milliliters, and we are looking for the initial concentration. So plugging into our equation, we get that the initial concentration multiplied by 450 milliliters equals 0.8 molar multiplied by 900 milliliters. So we have 450 times the initial concentration on the left side, and that equals 720. Next, we would divide by 450 to get initial concentration alone, and doing that, we get that the initial concentration of KBr is equal to 1.6 molar. Lastly, we're going to calculate the new concentration after we've diluted it. This is probably one of the most common calculations that you'll be doing in a laboratory setting. So, a student has 300 milliliters of a 2 molar solution of NaOH aqueous and dilutes it to 450 milliliters. What is the new concentration? So as always, we have our equation M1V1 equals M2V2, and then we're going to list our givens. M1, or the initial concentration, is 2 molar. The initial volume is 300 milliliters. Our new volume is 480 milliliters, and we're finding M2, or our new concentration. Next, we're going to plug in our known values and get that 2 molar multiplied by 300 milliliters equals our new concentration multiplied by 480 milliliters. Then we're going to take the product of the numbers on the left side to get 600 and set that equal to 480 times the new concentration. Lastly, we're going to divide by 480 to get that our new concentration of NaOH aqueous is 1.25 molar. Now that we've worked through solving for all four variables in our M1V1 equals M2V2 equation, here are 4 practice questions so you can try solving for it on your own. At this time, I encourage you to pause the video and try them. The answers will be provided for you on the next slide. The answer to the questions are as follows. The answer to question 1 was that the initial concentration is 1.8 molar. The answer to question 2 is that the new volume is 200 milliliters. The answer to question 3 is that the initial volume was 12.5 milliliters. And lastly, the answer to question 4 was that the new concentration is 2 molar. If you got all these right, great job. If not, feel free to watch the video again or leave any questions you might have in the comments below the video, and I will get back to you as soon as possible. Thank you so much for watching, and have a great day.